Hello, my name is Eduardo Deresa. I am a development support engineer working in the industrial and timing division at ON Semiconductor. Today I'm going to be talking about our multi-rate clock generator with low noise that makes it perfect for telecom and networking applications. So today we have the NB3H5150 demo board. We have the NB3M AT3910G, which is an LV-PECL fan-out buffer. Now this line goes into our phase noise analyzers that is currently measuring the phase jitter spec on this part. As you can see on the monitor, we are about 226 femtosecond, which meets the Broadcom 300 femtosecond max spec. A second item that Broadcom requires is very fast transition times. The NB3H5150 can supply 300 picosecond max LV-PECL waveforms, as well as 1 nanosecond LV-CMOS rise and fall times. Both the LV-PECL and the LV-CMOS rise and fall times of the 5150 meet the Broadcom spec. Now I've talked about a little bit of the performance of the NB3H5150. Now let's talk about its flexibility. The NB3H5150 is extremely flexible. The user can select between LV-PECL outputs and LV-CMOS outputs across 4 output banks. 3 of the output banks are integer N frequencies, while the 4th output channel can be used with integer N or frac N frequencies. The NB3H5150 comes pre-configured with 18 default frequencies that the user can select from. Look how easy I can change the frequency on the NB3H5150 clock 1 output by just changing the logic level on one of its frequency select pins. So currently now it is at 33, and now I can change it back to 25 and changing it back to 33 very quickly. Previously I mentioned that our clock 4 output had integer N and frac N frequency outputs. I'm going to go ahead and show you an integer N and a frac N frequency. Currently, I have frequency select pins on clock 4 output showing 125 megahertz LV-PECL output integer N frequency. Now, by just switching the frequency select pins on channel 4, I'm going to show you a frac N frequency. Okay, so previously we were reading 125 megahertz LV-PECL integer N frequency. Now we are reading 106.25 megahertz LV-PECL frac N frequency. In the case you do not see the frequency you would like out of the 18 default frequencies, you could also communicate to the part via I2C. With I2C, the user can select any frequency up to 250 megahertz. As you can see on channel 1, I have a 25 megahertz LV-CMOS signal, 100 megahertz LV-CMOS out of clock 2. I have a 50 megahertz LV-PECL out of clock 4, and I still have the 156.25 megahertz LV-PECL on the phase noise analyzer. So now I'm going to go into the customer GUI and change the frequencies. I'm going to go ahead and change clock 1 to 50 megahertz. Change clock 2 to 25. Change clock 3 to 166.667, and change 50 megahertz to 100. Gonna upload to device and watch for the frequencies to change. Frequencies change instantly. I now have a 50 megahertz LV-CMOS signal, followed by a 25 LV-CMOS signal, 100 megahertz LV-PECL signal, and now I have 166.67, and I'm still below the 300 femtosecond phase jitter spec. With the high performance and the flexibility of the NB3H5150, you can eliminate multiple crystal and crystal oscillators to reduce board complexity and cost, combining multiple crystals in just one IC to solve all your system needs.